variable or number, they give you, yes?
A is 8x squared.
How many people agree that A is 8x squared? They're very good. How would you check? And how would you know that A is this time 8x squared? You basically do 8x squared times 8x squared. And does that give you 64x to the fourth?
Yes.
Good. What about B? Who could tell me what B is this time? It's not a number anymore. It's just Ryan? I mean, yeah. Yeah. What do you think? Yeah. Victor? 5y. Ryan, do you agree? Why, Ryan? Why would it be 5y?
5 is 25 squared.
Yeah.
Is the factor.
Uh-huh.
And then 8 is the 8x squared factor.
What about what? He said 5y though.
Oh.
So how do you know it's 5y is the B this time? Because you do 5y times 5y gives you 25y squared. Would you agree that if it's this pattern, 8x squared whole thing squared minus 5y whole thing squared? Is that right? Do you think it's a good idea to kind of put this into this form to see what my A and B's are? Yeah, I think this is a great idea. Okay, does that make sense? Even though I figured this, even though I'm the one that actually figured this out. Yeah, you should all it's a great idea. You should always put these parentheses. I'm not the only one, I'm sure. But you should always try to figure out, right, what A and B's are by plugging into this form. You see, then you can see your A and B really easily. So now that we know this, who could tell me how to factor? How about Caitlin? Can you tell me?
Okay, so when you factor, it becomes 8x squared plus 5y, and that's in parentheses, and then
Good.
8x squared minus 5y.
Excellent. Did you all get this? Now, obviously, I don't really need the parentheses around here, right? But I just still put it there. I could get rid of it if you want. Any question? Okay. So yeah, you shouldn't really leave these parentheses, so I wrote it again. It's 8x squared plus 5y, just like Kate said. 8x squared minus 5y. Any question? So as you can see, your A and B do not have to be really simple. Does that make sense? Do you understand what I'm saying? So can A be like this? What if I had heart square minus triangle square? You know, instead of some letters, could it be some kind of symbol? How would this be when you factor this? Just for fun. What would that be? Yeah.
Heart plus
Huh?
triangle.
Uh-huh.
And then heart.
Yeah. It'd be heart plus triangle times heart minus times, right? That's important because it's factoring. You want to be as product. Heart plus triangle times heart minus triangle. Does that make sense? And in place of heart and triangle, you could put in anything you want, right? You could plug in some monomials. That's kind of interesting. Or you could actually plug in polynomials in there too. As long as there's something squared minus something else squared, you could always use this pattern, right? If it's a difference of square, it always factors out to be, you know, the first term plus the second times first term minus the second. Whatever the first and second term is. Does that make sense? It doesn't have to be some numbers or one variable. It could be a monomial. It could be a polynomial even. Does that make sense? All right, good. By the way, one of my favorite food is onion. Anybody like onion? No? You guys don't know? Really? No, I love raw onions, by the way. You guys don't? No? You guys don't like what? You don't? Really? I love it.
I like sauteed onion.
Saute onion, yeah. But then you lose all the taste. You love that. Well, I love it, but then people around me don't like it. But anyway, you know, I'm gonna call this problem. Let's see. The onion problem. How did you guess that? Yeah. Yeah, you see why it's called onion problem in a minute. Try this one yourself. Okay, everybody go ahead and try. And I like to call this problem an onion problem. Go ahead, everybody try. Alright guys, by the way, what do you notice? Have you guys ever peeled an onion? What happens as you peel the onion? You have layers, right? You cry, okay. But then you have layers, right? You know, you have layers and layers. Okay, so, by the way, how many people noticed that, was there any GCF for this anyway? There was GCF?
No.
For 81 and 16?
No.
There wasn't any GCF, was there? Yeah, there's no GCF. So no GCF. Okay, I didn't write that, but then only other way of us knowing how to factor is difference of square. Is this going to be difference of square? In other words, would it be something square minus something else square? What's your A for this? Raise your hand. A lot of people figure this out. Okay, William, what's my A?
9 squared
Good, very good. 9x squared. What's my b, William? 4. 4. Well, 4 is your b, and you're squaring b, so it's 4. 4 is your b, and yeah, you're right. Parentheses b squared. Yeah, exactly right. So if I have this, everybody now should know. Every time, Jamin, tell me what to write. When I have, now that I know that this is a difference of square, what does it become?
9 squared is 4.
Good.
9 squared minus 4.
Yeah, I just wrote 9 squared minus 4 first. Is that okay? It doesn't really matter, does it? Okay. How many people got this? Raise your hand. Raise your hand. Good, good. I'm done, right? No? You're right. Because if you give me this as your answer, you only get half points. You only get 50% on this one. Why? Anybody see what? Raise your hand. Who sees it? And why do you think I call this as an onion problem? Anybody see? Lucia. Oh, it should be 9x squared plus 4 and then 9x squared minus 4. It doesn't really matter because it's, you know, multiplication. You know, multiplication is commutative. It doesn't really matter. But if you stop here, you will get only 50%. Eddie, you see why?
You need to check.
Well, I don't really require you to check unless you have time. But yeah, that's not the reason why. Okay, you're right so far, but you're not quite done. I'm saying if you stop right here, you only get 50% on your. Paul. I can factor it again. Paul, how? I thought I was done. How do you factor this again? Why? How? Yeah, look at 9x squared minus 4. That's again a. What's that again? That's a. Yes. Difference of square, isn't it? What's your a for this one, guys? Yes, Victor? 3x. What's my b, Ryan? 2. Do you see how this is a difference of square? Could we do the same for the second one? No. Is this a difference of square? No, this is sum of squares, isn't it? And guess what? Sum of squares. Do you think you could factor sum of squares? No. If you could, I would have told you. Okay, you can't. Okay, so leave it alone. Don't try to factor something you can't. Then you get it wrong. Do you see why you could actually factor this more? So what's your a for this? Is a for the first term is? What goes in here? Yes. 3x. What about the second one? 2. Would you all agree, guys? So, who can tell me then what I should do next? 2 people see it. Anyone else? Yes. I'm sorry?
Do you factor the other side?
Yes, I factor, not the other side. I factor the, what does it become?
Becomes 3x squared minus 2.
3x squared? No. This is your a. Your a is 3x, your b is 2. So it becomes 3x.
3x.
Yeah, so let's remember how we factor the difference of square. If it's a squared minus b squared, it was a plus b times a minus b. So guess what this becomes? 3x
Oh, 3x plus 4.
plus 4 or plus
Plus 3x plus
2 times, not 2 squared, just a. This is your a, right? A is your 3x, your b is 2, so it's going to be a plus b times a minus b. So it's b, 3x.
3x. I get what you're saying. I just can't put into words.
Okay, well, let's try it again. Your a is 3x, your b is 2, right? If I have a squared minus b squared, what does that become when you factor? A plus b times a minus b, right? So, what is going to be a plus b? 3x plus 2 times 3x.
3x minus.
Yeah, just plug in a and b, that's all. Does that make sense? Okay. Oh, no, never mind. Don't worry about it. Do you see why I call this an onion problem? Why do I call this an onion problem, guys? Yes.
Because you're like doing different layers.
Yeah, even if you factor one layer, there's another one to factor because there's another layer for you to deal with. Yeah, like an onion. Okay, that's why it's called. Does that make sense? So be careful of these onion problems. Just because you factor once may not mean that you're done. You have to look at the, the factors you get and see if you can factor any further. Does that make sense? Because just like simplification, can you simplify kind of like when you simplify some numbers, can you stop in the middle of the simplification? No, you simplify all the way, right? So factoring is same thing. You need to factor all the way. In other words, after you're done, you should not be able to factor anymore. Does that make sense? Okay? Because if you could factor more, then you're not done with factoring. You see what I'm talking about? Also, I want you, this is what I wrote down. Do you think sum of square is factorable? It's not factorable, is it? Like some people think that 9x squared plus 4 is factorable. It's not. Think about it. A squared plus b squared is not factorable. Some people think it's a plus b times a plus b. Do you think that will get you a squared plus b squared? No. Why not? Because when you multiply a plus b times a plus b, your linear term what? Doesn't cancel. You get two of those. What about a minus b times a minus b? Do you think that will work? No, still, it will still not cancel. You will get negative of both of a, b, right? Does that make sense? So please note that sum of squares is not factorable. Don't try to factor something that's not factorable and get it wrong. Does that make sense? Yes?
When I saw the thing with a squared plus b squared.
Uh-huh. Which one?
So that would be a squared plus 2ab.
Yeah, exactly.
Would that be the square of a plus b?
That's exactly right. We're going to talk about that tomorrow. It's called perfect square. And then, yes, that's the pattern that you're going to learn. And we're going to be able to go backwards. Excellent. Yeah, question?
So, where do you want us to simplify the 9x squared plus 4 on the right?
Oh, how would you simplify this further? Is there a way to simplify 9x squared plus 4 more? No, there isn't any way, right? You can't factor that more. You're done. Does that make sense?
Yeah.
Very good. And Leah said something very interesting because she notices, wait a minute, that thing is going to have a pattern too then. So that's what we're going to talk about tomorrow. Okay, very good. Any question? Any other question? Does this make sense? Let's move on. Yeah, question? Go ahead and everybody try this one. I put 2 stars on this. This looks very simple, doesn't it? It's very, very innocent looking. Nothing hard, you know. I put 2 stars on this one. Everybody try. Go ahead. Is this difference of square? Right? 3 is not a perfect square, right? It's not like 4 or 16 or 25. But I tell you that you could actually factor this. Everybody try. Let's see who's been actually listening to what I have to say. One person's here. Oh, you see it? Okay.
I see it.
You see it too? A lot of you? Very good. Very good. Ethan, what did you do first? GCF. Ethan, what's the GCF of this? Always do GCF. What's the GCF, guys? 3. Okay, so you first said, wait, it's not difference of square, right? But you shouldn't have thought of that first. You should always look for GCF. Because if you saw the GCF, then how many people wrote this down? Raise your hand. Okay, you only get 50% if you do this. You're not done still. Turns out this is it's an onion problem, guys. How is this an onion problem? I don't see any something to factor. Jimin? Yeah, x squared minus 1. Turns out that is a difference of square. Wait a minute, I don't see anything squared. 1, I don't see any square for 1. But what's 1 times 1, guys? Do not forget the easiest one to okay? 1 is a perfect square. That's the easiest perfect square. Don't forget, 1 times 1 is 1. Okay, so be careful. Just because it's not 4 or 9 or 14 and so forth, right? No, 16, 14. 14 is not perfect. 16, okay? 1 is a perfect square. That's why a lot of people mess up. 1 times 1 is 1. Be careful. So, who can tell me what I write? Vlad, what does this become? X plus 1. Very good. Everybody see this? Now we're done. Okay, please don't stop halfway because you only get 50% if you do that. Does that make sense? You get this? Pretty interesting, right? Hey guys, let's switch your gear a little bit. Now, I don't want you to factor. Now, I want you to do the other way. I want you to multiply this out. And on the homework, it says 62 times 58. And you say, what? You just multiply, right? There's not. Why are they giving this all of a sudden when we're talking about difference of square? And this one is not even factoring. Why would they give you this? Oh, Sarah, you see it? You can factor the answer. This one, they just want you to multiply. So they don't even want, this is already factored. Right? Isn't this factor form? Something times something, right? So they don't want you to factor the answer. It's already factored. Why are they yeah, do you see it? Oh, do I find the prime factorization? You could do that. But why do you think they give this to us in the middle of difference of square? Paul?